I bought this programmable electronic load, a DLP or DL24P it is, and I was testing this thing to see out of curiosity, because this thing will talk to a PC. You can program it from the PC and everything, and it's been pretty cool. Let me show you what it is. It's this I bought it off Amazon here for like 79 bucks. Um, can't remember if I had a coupon or not, but anyway, it's pretty cool. But anyway, it has a constant resistance mode, and I'm just trying to understand exactly how these things work, because I heard that they actually use these FETs in switch mode. Um, it's like supposedly a 180 watt deal, but I haven't tested it anywhere near that. I've heard some horror stories. I don't know if I'm going to need to test it that high, because I do have a programmable electronic load, my um, by GW Instech, that I hadn't used in a long time. It's fire damaged, but it's a 300 watt one, but it's also kind of complicated to use. So this one, that's what I liked it. You can hook up to the PC. What I don't like about it's no goddamn case, but there's plenty of 3D printed cases out there. That's what made me finally decide to buy one of these, instead of the alternative, because they had like a you know LP24M or something like that on eBay. Let's see. Yeah, it's like this. Right here, this is it. Again, Chinese aren't really all that big on part numbers, but it's modular, so you can buy, each module is 150 watt, and you buy the main module, which you hook up to your load, and then you can expand it. And they're cheaper versions than this too. But again, I think I've discovered at great length that it, is actually, it's a DL24M or something like that. Let's see. Because you got the single modules you can buy, and they can buy multiple modules here depending on what you wanted. But of course, they proportionally cost more. But anyway, I was really tempted to get this one because it has a control panel on it. And this isn't the best one. I mean, I'm just really frustrated trying to find these goddamn things. That this shows the control panel detached, but the one I was going to buy wasn't like that, and I don't know what the fuck I did with it. Um, yeah, 24 MP. Yeah, here it is. See, this is like 58 bucks. So, and $5 in shipping. But anyway, the point is that they had the display. It's the same damn thing we saw before. It's just they have the display mounted, which is even better. They have it mounted on standoffs, but it still has the cable with it and everything. And as you can see, it's got 4 FETs instead of 1. Like this only has one beefy FET. This has four less beefy FETs, but they're spreading the load around. So I kind of like that, even though it's got a wimpier heat sink on it and a wimpier fan. But it's still, you probably don't need as good of a fan if you're spreading the load out like that. And they got these 4 power resistors here too, which as far as I can tell, this doesn't have any that I can discern. But at any rate, it has the control panel, with buttons and everything on it, and it's detachable. So, I was like, how great would that be? You could take this thing, because see, it's got a ribbon cable here. You could take this thing, stick it in a box, and put the display wherever you want, okay, and then put this thing elsewhere in the box, to where you got, and just actually take some wires, all right, and run it to some, some like banana plugs or something like that, because I got some hefty banana plugs. And then Bob's your uncle. You got a nice self-contained bench unit that you can stick on your bench, on your rack. But, um, but as it turns out, I saw a review on this damn thing, and there's not many of them. But I saw a review on them, and you apparently can't turn the fan off. That's what the guy said. He could find any way to do it. And I did my own research, and yeah, there's no way to turn the goddamn fan off. It's on 100% of the time. Anytime you turn that damn thing on, the fan's on. And it's like, man, that'll drive me fucking crazy. There's no fucking way. So I changed my mind about buying it and decided to buy the more expensive one on Amazon. Even though I really did prefer this one, even though it's only 150 watts versus 180 for the Amazon one. But anyway, the point is that there are different options on these. These are kind of cool, though. They're really kind of worth having because you can test, constant current, constant power, constant voltage, whatever that is, and constant resistance mode. Well, I was wondering if the constant resistance could be used like a potentiometer, because like I said, how cool would that be to be able to freaking have a resistor you can control from your computer to control, different things, with a power resistor that's variable. I was like, a variable power resistor would come in handy. You know why? Because those damn, resistor substitution boxes are easy to blow up if you're, if you're not careful. I mean, I've definitely toasted a few of them in my time, because they only have half-watt resistors in there. So, trying to get the wattage right, and remember how many you're adding together. Hell, I'm not even sure most of the time how they're even routing those inside that box. I've never actually taken one apart. But, it's like watch a YouTube video on it. But anyway, the point is that it would be still cool to have a power resistor that's variable, like a resistor substitution box. And I know that's a little much to ask out of a FET-based system, right? But, FETs, some FETs can be used like a variable resistor, right? So, and MOSFETs are no exception. You can use those like a variable resistor too. But over a range, there are limits to it. But I was just kind of curious what what it would be like and how this thing would behave if you tried hooking it up that way. So right now, I've got the settings set to a total of like 105 ohms. This is a 100 ohm, 300 watt power rheostat, or potentiometer really. But I got it set to like 100 ohms right now. So, and I'm still not sure because you can tell I'm measuring my potentiometer across the device, and that's the waveform we're getting. It's like a 2 hertz signal. So, it's 2 hertz, 1 to 2 hertz. But yeah, it's like a pseudo sine wave at 2 hertz. It's really bizarre. But you only get that once, this resistance starts becoming about equal to that resistance. You can see what the power draw is and what's going on with the, current and everything. It's pretty dodgy. So I was hoping it would be like at a high frequency or something. I wasn't expecting it to be at a 2 hertz frequency. I was definitely expecting to see something being chopped, because that's how I was thinking these things work based on what some people on the internet were talking about. But, if you take and start varying this, I'm going to start lowering the resistance on this potentiometer. So more and more of the load is, because let me turn it back up for a second, because you can see that the current, this is measuring like 1.1 or 2 watts, and the current, is, like, get confused, less than 100 milliamps. But, I'm going to start turning this up, so more of it, hold on, let me turn it back down. Really confuse this thing. Alright, so this modified sine wave or whatever you want to call it is definitely a stepped pseudo sine wave. But yeah, okay, so let's do this again. See if I can get everything in the shot. Okay, I'm going to turn the potentiometer down to where more and more of that load is actually going to be impressed across the device. And you can see what the display's doing. The sine wave gets lower and lower and lower as I approach 50 ohms. So it seems like this thing gets confused for some reason, when the resistors are about equal. So, but you can tell that its voltage, has certainly changed. It's increased. But, it's a lot flatter on the scope now. And let's see, we got it set to, well, it's measuring 16 volts across the device, which is pretty much what it says, although it's still a little confused. Okay, and keep lowering it. It becomes flatter and a lot more stable. So, I mean, evidently, yeah, you can do that to some extent. And you can continue to do it. The voltage rises. So more and more of that's being impressed across the load until you go down to, like a 20 ohms now, I'd say. But, it's constant resistance, so it's still set at 105. But the current's gone up to 200 milliamps now. So, the wattage is closer. It's 5 watts total because the total resistance is decreasing. At least hypothetical resistance. I don't know what you would call that, honestly. But, I don't know. It's just interesting because it's actually pretty well behaved. Because I was expecting this to be all chopped to hell. I was like, this thing's going to look like chop suey because, I heard that they were using these FETs, in switching mode like you would with an SMPS. But apparently they're not, because I was like, that sort of, I don't know. I wasn't surprised they weren't doing that because I would actually be inclined to use it in linear mode. You can have it dissipate more power, though, as a switch mode. In switch mode, you can. And, you can get more power out of it if they did it that way. On the other hand, man, that's one hell of a dynamic load on your power supply. So, it's really bizarre. In fact, I'll go ahead and, switch it over. Yeah, switch it over to constant power, constant voltage, constant current mode. I'll go ahead and, for now, I'll leave it at, okay, so, I got a constant current, and that's what's nice about this. The fan doesn't come on unless this thing starts seeing like 9 watts typically, although there's been some variation in that, and I'm not sure why, because see, it's about 7 watts right now. But the whole thing is like at 14 watts, because I still got it connected to the potentiometer. But you can see what the scope is doing. It's actually well behaved. It's flatline. So it's like they really do have constant current going through this thing. So, so we got it, the end of the current, 600 milliamps, like I have it set to. So, but even at that low of a current, it's well behaved. Now let me see what my current limits are. Okay. Because, if this thing hits your current limit on your power supply, it'll just immediately go done. So, which I thought this thing was broken for a while because it kept doing that, but apparently that's not the problem. Okay, that's 7, 8, 9. This fan will kick on in a second here. But, so we're at 900 milliamps. You can see what the scope's doing. Alright, so that's the voltage level across the device compared to, again, it's 25 volts there, but, if I keep going, we're down to 5 volts here. So, if I up the resistance too much more, if I lower the resistance, the voltage increases. But I got to be careful not to up it too much, otherwise it'll drop down below that threshold and it'll think it's done. So I can't really, increase the thing very much, but let me lower it a lot. But, I'll vary it, like I said. Okay, see, it comes on because now the wattage has gone to like 16 watts. Total wattage is 22. Because I don't have the potentiometer all the way. That's all the way. Alright, you can see the waveform there, Because, I got this set really low. Let me speed this thing up. As I had it set really low to see that 2 hertz pseudo sine wave. and I'll put it to 1 millisecond. But yeah, kind of watch it as I turn it up and see the thing's still on. But you know, you can see the voltage is diminishing across it. And here are the parameters. You know, we're down to 17 volts. It's still, you know, again, it's constant current, so 900 milliamps. Yeah, you see it stopped. You know, the thing's still on, you know, but our voltage has dropped down to 8 or 9 volts. Still our power supply setting, 22 watts. But, you know, the amount of power this is dissipating has dropped below 10 watts, 9 or 10 watts. So, but again, it's actually a pretty stable waveform. There's really no hint. This does not actually act much like a switch mode power supply, at least not at these levels. Again, that may change as you increase the actual power on this, you know, but see, you know, we're down to 4 volts, all right, and the voltage across our unit has dropped, you know, considerably compared to that. So we're dropping most of our voltage across this. And again, this potentiometer can handle like 1.75 amps sustained. So right now we're only doing 900 milliamps. But let me show you what happens if I increase it too much and the voltage drops too low. See, we're down to 2 volts now. Oop, now it's complete. So, but yeah, I mean, it's, you know, at least at low current levels, you know, it's relatively stable. Again, I haven't seen it at high current levels because that's actually harder to arrange. You know, again, this thing has a limit of 1.7 amps. Even though I can do it, I can apply much more than that. I mean, hell, I've put, you know, 15 amps through this thing before. As long as you do it very briefly, it's fine. And I do have some bigger potentiometers, or well, not potentiometers, but bigger, you know, resistors that, you know, like a 2 ohm super power resistor that's probably rated at like 1500 watts or so, but it's not variable, not really. I mean, it has fins on it though, so you can theoretically vary it. But anyway, I just wanted to demonstrate the weird, interesting waveform this thing did as a resistor. It was just a point of curiosity. I really wasn't expecting it to be as good as it is, you know, in terms of that, or in terms of this. I mean, you know, because hell, this is halfway decent that you can actually use it this way and have it be a fairly stable waveform. But again, I don't know if there's a practical use for it beyond just as an electronic load, but I'm just curious about things like that, and I've definitely been curious about having a power resistor substitution box. I mean, how great would that be? But at any rate, you know, I doubt this will work for that, but still, it was a point of curiosity I wanted to investigate. Anyway.